Hello, welcome to Unit 5, Lesson 1. I'm Professor Blackman. In this lesson, we'll be talking about rational expressions. We're going to look at their domains, how to simplify them, how to multiply them, and how to divide them. And if necessary, simplify them after multiplying and dividing. On this slide, I have some notes here. Just as a reminder, how to divide. If you have the same thing in the numerator and denominator, they will divide out evenly. I really like this one here because it's the common mistakes that students make when trying to divide, and it's canceling out uh, when you have addition on top and bottom. And remember, you can only cancel out division when it's a factor. I really like this last one because it's just completely silly. And then as a reminder, how do we divide fractions? So we keep the first fraction the same, change division to multiplication, and apply the reciprocal to the fraction that follows. Some people like to say keep, flip, change. All right, let's look at some examples. All right, so what we're going to do is find the domain. So the domain for a rational function has restrictions when the denominator equals 0. So what we're going to do is set the denominator to not equal to 0, and that will tell us the restrictions that we have. So this would be x cannot be 3. So x is all real numbers and cannot be 3. All right, let's go to the next one. So here we're going to set the denominator equal to 0. T squared minus 3t minus 28 should not equal 0. And this is a quadratic, so we're going to do that one by factoring. Two numbers that multiply to give you negative 28 and add to give you negative 3 should not equal 0. And that would be a negative 7 and a positive 4. So let's go ahead and set each one of those. T plus 4. And we get t cannot be 7 and t cannot be negative 4. So x is all real numbers and I put x. T is all real numbers and t cannot be negative 4 and 7. All right, let's look at some more examples. All right, in this one we're going to simplify. So we can only simplify when we have factors broken down. So we're going to see what the top and bottom have in common. If you factor out a 3, you get 4x minus 5. And the bottom has the factor 3 in it as well. And so these, once we have these 3's, we can cancel them out. And now we're left with 4x minus 5 over 7. All right, let's do it again. So we need to factor the top. And that's difference of squares. So we will factor that way. And I have shown how to do that in previous videos. And on the bottom, that is a perfect square trinomial. So that's going to be t minus 4, t minus 4. And you can see that we have the factors that are the same on top and bottom, that t minus 4. So we will cancel that out. And now we're left with t plus 4 over t minus 4. All right, let's look at some more. All right, so we're going to look for, because it's two terms, we'll always look for the GCF first, and the GCF is 4. Factor that out. Factor the 4 out on the bottom as well. And now you have those 4's that are the same on top and bottom that can be canceled out. And then we're left with y minus 3 over y plus 3. The next one, we're going to factor the trinomials on top and bottom. Two numbers that multiply give you 8 and add to give you negative 9 are x minus 8 and x minus 1. On bottom, Now, because we have those two factors on top, we probably need one of those factors on bottom to cancel out. 8 is not a multiple of 4, so I'm going to use x minus 1. And then, sure enough, this will be x plus 4. And again, if you're not confident in your factoring skills, it's always important to check. X is x squared. Negative 8 times negative 1 is positive 8 on the backside. Negative 8 plus a negative 1 gives you the negative 9x in the middle. On the bottom, x times x is x squared. Negative 1 times 4 is negative 4. 4x on the outside, negative 1 on the inside. 4 minus 1 give you 3. Okay, and so now we can cancel out those common factors that are on top and bottom, and we're left with x minus 8 over x plus 4. All right, so this one right here, I will tell you to star. This is one of the ones that students really struggle with finding its factors. But if you notice, we have x in the front, and on the bottom we have x in the back. So what we want to do is flip that around. And now that you see that there's a leading term that's negative, we're going to factor that out. So then I'll pull out that negative 1, and I'll have x minus 8. Well, now you can see that you have x minus 8 and x minus 8. And so now we have 1 over negative 1, which will eventually just be negative 1. So on this one, we have difference of squares on top and difference of cubes on bottom. So we're going to break that down as a minus b, a plus b. And if you're not sure where I'm getting that from, I have shown that in a previous video. And then we have a minus b, same sign, a squared, opposite sign, first term times second term, always positive, and last term squared. And so now you can see that we have an a minus b on top and bottom. We're going to cancel those out, and we're going to be left with a plus b over a squared plus ab plus b squared. All right, let's look at some more. Okay, so now we're going to be doing some multiplying. Well, we know with multiplying that a over b times c over d equals ac over bd. So if we have anything on top, that can be canceled with anything on the bottom, just like when we are simplifying. So when you have a problem like this, the first thing you want to do is factor everything. So x minus 4, x plus 4. I'm going to take x squared and rewrite it as x times x, because those are its factors. The one on top here has two terms, so I'm going to do GCF, factor out that x, and that leaves x minus 4. And then this one on bottom will be x, and then two factors that multiply give you negative 12 and add to give you a negative 1. That's a negative 4 and a positive 3. And so now when we start to cancel, this cancels with this cancels with that, and that's all we have. So on top, we have x minus 4, x plus 4. On bottom, we have x times x plus 3. Now you can multiply this out, but the factored form is always an acceptable answer. So I would leave it here because it's less work. All right, let's look at number 2. Again, difference of squares. So y minus 4, y plus 4. Two terms, so I'm going to do GCF, factor out that GCF, and that give you y plus 3. And these are already just a binomial. Nothing we can do to factor those because they're already in simplified form. So y minus 4 cancels, y plus 3 cancels, and now we're left with y plus 4 over 2. Now don't cancel this because on top is addition, not factors. All right, so that is simplified. Let's look at another page. All right, So again, even though this looks a lot longer, the process is the same. Start by simplifying. Factor everything you can. So we get x minus 7, x plus 5, because negative 7 times 5 gives you negative 35. Negative 7 plus 5 gives you negative 2. Two terms, so I'm going to factor out the x squared, and that's going to leave 2x minus 3. I have an x that I need to factor out, and that'll give me 4x squared minus 9, which is difference of squares. So I'm going to do x, 2x minus 3, 2x plus 3, and then pretty sure I just did this one, x minus 4, x plus 3. All right, now what can cancel out? So we have 2x minus 3, 2x minus 3, and I have an x here. It's going to cancel out one of those, and that's all we have. So on top, we have x minus 7, x plus 5, and 2x plus 3. Now don't cancel out 2x plus 3 with x plus 3 because it has that 2 in it. On bottom, we have x, x minus 4, x plus 3. All right, let's look at another example. C cubed plus 8. So remember that's difference, or sum of cubes. So I'm going to rewrite that rule here. First term, second term, first term squared, opposite sign, first term times second term, always positive, last term squared. So that would be c plus 2, c squared minus 2c plus 4, because that's 2 squared. All over, difference of squares, c minus 2, c plus 2, times c minus 4c plus 4. Well, that is a perfect square. That's c minus 2 times c minus 2. And c squared minus 2c plus 4 is prime, but we can clearly see that this and this are the same. That and that cancel. That with that cancel. So now we have c minus 2 over 1, which would just be c minus 2. All right, let's look at our last examples. All right, so in this problem we have division. So what we're going to do is take 4a squared minus 1, a squared minus 4, change it to multiplication, and do a minus 2 over 2a minus 1. And so now it's a multiplication problem like we just did, so we should have no problem doing this. It's just that one step to change that division into multiplication. So we have a difference of squares on top, so that's 2a minus 1, 2a plus 1. On bottom, difference of squares as well. It's a minus 2, a plus 2, times a minus 2 on top, and 2a minus 1 on bottom. And we can see that this a minus 2 will cancel, 2a minus 1 cancels as well. And so now we have 2a plus 1 on top, and a plus 2 on bottom. All right, here's our last problem for the day. We have going to factor that to x minus 4, x plus 4. On bottom, we have x minus 5, x minus 5, because that's a perfect square. This will be 3 factored out, x minus 4, which After applying the division, we'll move to the bottom. And then this is x minus 5, x plus 2. Negative 5 times 2 is negative 10. Negative 5 plus 2 is negative 3 in the middle, which is now on top. X minus 5, x plus 2. And now we can start canceling things out. X minus 5 cancels, x minus 4 cancels, and that's all that cancels. And now we're left with x plus 4, x plus 2 on top, and a 3x minus 5 on bottom. That's all I have for you today. Happy studying.